A051 Output Interfacing Part 2. The 7-segment display can display any number from 0 to 9. It is basically made up of 7 LEDs packed in a module. The 7 segments are named A to G. The LED in the 7-segment module can be connected in a common anode or common cathode configuration. In the common anode configuration, all the anodes of the LED are joined together to a common point. Our explanation will be done using a common anode 7-segment display. The common anode point is connected to a positive voltage. To light up a segment, the respective segment point is connected to 0. The example shows how to light up segment A. By controlling the logic at the pins of the 7-segment display, one can display different numbers. Example: to display the number 1, segment B and segment C inputs are fed with 0 in order to turn on the B and C LED. Explore how you could change the display by changing the input signal. The 7-segment display can be connected to the I/O of the A051. If the port signal at initialization is all 0, then all the segments will be lighted up. The following instruction will result in a 2 being displayed. To display 2, all segments should be lighted except segment C and F. Therefore, the signal at segment C and F should be 1. This means that port 0 register should contain 0010, 0100, or 24 in hex. Note that P0.7 is not used. Therefore, it doesn't matter if P0.7 is a 0 or 1. Both the following instructions will display 2. Explore how you could change the display with the different value moved to port 0. .40 hex will display 0. 79 hex will display 1. 24 hex will display 2. 30 hex will display 3. The buffer IC, such as the ULN2803 transistor array, is sometimes used to allow more current through the LED. The ULN2803 is an inverting buffer. Explore how you could change the display by changing the value moved to port 0. Figure out how you could display numbers 0 to 9. 0 is displayed if the data BF is moved to port 0. 1 is displayed if the data 86 hex is moved to port 0. If data DB is moved to port 0, 2 is displayed. To quickly determine what is the value to move to the port for displaying numbers, we use a lookup table. How do you display a 1, 2, or 3? This is a lookup table. This first column represents a digit for display. The second column represents the port data in binary for displaying the number. For example, to display 0, what should be the port data? The port data should be 0011 1111. This binary value in hex is treedef. Try to figure out the data for displaying 1. Port data 5B will display 2. 4F is for 3. 66 for 4. And so on. The lookup table is complete. What do you move to port 0 to display 5? Get your answer from the lookup table by looking up at 5. The data to move to port 0 is 6D. How to write a program to display a running number of 1, 2, 3. To display 1, output 06 to port 0. Insert a delay. To display 2, output 5B to port 0. To display 3, output 4F to port 0. Jump back to M1 to repeat the cycle. How to place the lookup table inside the 8051 program memory space. Check out the program on the left. DB is called the define byte directive. Check out the machine codes generated by the define byte directive. The machine code for DB3F is 3F. The machine code for DB5B is 5B. The machine code 3F is stored in code location 0050. This is due to the ORG50 directive. The rest of the code are stored in locations 0050 to 0059. The program results in the lookup table being stored in the program memory in location 0050 to 0059. Let's try to understand how the given codes make use of the lookup table to display number on the 7-segment display. These codes place the lookup table information into the program memory. This instruction results in the DPTR containing the value of 0050 because look is a label which is located at 0050. To display a 1, simply copy 01 to the accumulator. We shall see how the program goes to the lookup table to pick up the port data to display 1 on the 7-segment display. Now, evaluate this instruction. The content in the accumulator is 1, and the content in DPTR is 50. Accumulator plus DPTR becomes 51. The system goes to program memory 00512 to pick up its content and then copy it to the accumulator. The content in program memory location 0051 is 06. Therefore, the accumulator becomes 06. The next instruction, copy the accumulator to port 0. Port 0 becomes 06. Trace the signal. The number 1 is displayed. Therefore, to display 1, simply copy 1 to the accumulator. This instruction will pick up the data from the lookup table. The data from the lookup table is then sent to port 0. This results in the display of 1. Let's remove the buffer from the circuit. Can the same program be executed on this circuit? Let's evaluate. The data 06 is copied to port 0. Trace the signal at port 0. Segments B and C are turned off, while the other segments are all turned on. The display fails to show 1. What seems to be the problem? We have come to an end of the lookup table method. We will be looking into other method to display numbers on the 7-segment display. The BCD to 7-segment decoder. The pin configuration of the BCD to 7-segment decoder is shown. It has 4 inputs and 7 outputs. The outputs are named A, B, C, D, E, F, G, each representing a segment of the 7-segment display. Let's simplify the representation of the 7-4-4-7 BCD to 7-segment decoder using the diagram shown. The circuit shows how to connect the decoder to the 7-segment display. The A output pin is connected to the A segment of the 7-segment display, the B to the B segment, and so on. If the input to the decoder is 0000, the 7-segment display will show 0. In order for that to happen, the decoder must output the relevant data. The table shows the relationship between the input and output of the decoder. If the input is 0001, the 7-segment will display 1, and this is the output at the decoder to display 1 at the 7-segment display. The entire table is shown. This is called the truth table for the decoder chip. The 7-4-4-7 BCD to 7-segment decoder can be driven from any of the I/O of the A051. What should be the instruction to display 5? Simply copy 05 to port 0. If the connection is changed as shown, can the same instruction display 5? The answer is no. A 0 is displayed instead. Trace the signal in the circuit to understand why this is so. The 7-segment display can be connected to the 8051 in different ways. It can be connected directly, or using a buffer chip, or using a decoder chip. End of 8051 Output Interfacing Part 2.